Hey, Med School Made Easy here with a quick review from genetics. High yield for boards, especially for review purposes, and very high yield for those taking a genetics course or a basic science course. This video is going to cover the differences between purines and pyrimidines. It's also going to talk about what the heck those two things are, for those of you who might have forgotten that. So to start, what are purines and pyrimidines? These are the two major groups of nitrogenous bases, is the fancy word, but the simple word is kind of the building blocks for very important things like DNA or RNA. Both these things, these nitrogenous bases, are added to other things like sugar groups and phosphate bonds, and they make up things such as nucleosides and nucleotides that eventually are built into chains that constitute a DNA chain or an RNA chain. So let's talk about how they're similar, let's talk about how they're different. Both these things, both purines and pyrimidines, are technically heterocyclic aromatic organic compounds. Now, what does that mean? It's been a few years since orgo. Heterocyclic means that they both are made of these chains that form a cycle or form a ring structure here, as you see. So purines have a double ring structure, whereas pyrimidines have a single ring structure, which is one of the differences between the two. However, they're heterocyclic, which means that the types of things that are in that ring, are not all the same thing. In these rings, for example, it's a mixture of nitrogen and carbon. So that's why they're heterocyclic. And aromatic, it refers to these lines here, which has to do with electrons moving freely throughout the ring. That's about as in-depth as we need to go for this particular discussion. But they're heterocyclic, aromatic, organic compounds. Now, as I already mentioned, purines on top here have two rings, a 6-member ring and a 5-member ring, whereas pyrimidines only have one. The other difference that I need to talk about here are the names of the types of purines and pyrimidines. So, for example, in your purines, you're going to have two types of purines. First one is adenine, or A, and the second one is G, or guanine. Now, one way to remember what's a purine versus something else is the mnemonic pure as gold. So pure, purines, as is adenine, gold is G, guanine. Now, pyrimidines, the single ring type nitrogenous base here, there's 3 different ones, and they're going to be cytosine, thymine, and uracil. Now the difference here is that uracil, as you probably remember, is replaced or exchanged for thymine when we're dealing with RNA. So thymine is for DNA, I'll write that down here, and uracil is for RNA. Uracil is actually a deaminated form of cytosine, but that's neither here nor there. The big thing with pyrimidines is the mnemonic cut the pi, and the cut is CUT, or the 3 types of nitrogenous bases here that make up pyrimidines, the, and then pi, and pi refers to pyrimidines. It also refers to the fact that there's only one ring, because you never have a double ringed pi. So that's another big thing. As far as a basic genetics course, really what they're going to care about here is what things are purines and which things are pyrimidines. The other big point here is that when you're making a chain, as a lot of you probably remember, you have one group on this side, one group on this side, and then you have this chain structure. And these things here, they make bonds with each other, right? And basically, all the bonds are constituted by one purine plus one pyrimidine. So purines don't bind to other purines, pyrimidines don't bond to other pyrimidines. So for example, one on this side could be adenine and thymine, or guanine and cytosine, that sort of thing. But it would never be like adenine to guanine. And the other big thing here, this is a very common one, is the number of bonds between these two things. This GC bond, the guanine to cytosine, has 3 hydrogen bonds, or 3 lines between it, whereas the adenine thymine only has 2. So I'm going to write 2 next to AT, or 3 next to GC. I just remember that gold is stronger than air. That's what worked for me. But in any case, having 3 bonds, as you might guess, is stronger than having 2 bonds. So it's less easily broken. The GC bond is. GC bonds have, if you have a higher amount of GC bonds in your structure, it's going to have a higher melting point. It's going to have a higher time breaking apart. And then the last little bit of trivia that's just kind of interesting for some reason for these board examinations or genetics test is this guy here. I'll use a different color. Thymine. What makes thymine different? It has a methylated group on it. It has a methyl, which is a CH3, if you remember. That's also kind of a common just trivia question, remember. So, pure as gold, cut the pi, U or uracil is for RNA, T, thymine is for DNA. GC bonds have 3 hydrogen bonds in between them, so they're stronger than AT bonds or AU bonds, which only have 2 hydrogen bonds. And that's it. You just nailed what purines, pyrimidines are, what their differences are, and why they're important. Thanks for stopping by, y'all.